Hello, what's up? So today we're gonna do some Leetcode because why not? And let's just do a Leetcode dialog questions. Let's see what question it is. Oh, reorder power of 2. So, dokie dokie. I love this question. I mean, I don't like this. I haven't looked at this question yet, but it sounds good. It sounds good. Reorder power of 2. You are given an integer n. We want to reorder the digit in order including the original order such that leading digit is not 0 and return true if we can do so. Make the resulting number is power of 2. Okay. So, right. How are we gonna approach this problem? So at first, given an integer, but if we want to reorder digit, then it's probably best for us to convert it to a string first. That's my first thought. And then, let's think about the potential outcome. So here, if it's 1, then obviously it's power of 2. But if it's 24, then we can either rearrange it to 42 or 24, but both are not power of 2. And let's give another example, such as 46. 46 can be rearranged to 64, and which is power of 2. And I'm like thinking of like power of 2 doesn't mean anything. In particular, what kind of pattern about power of 2? So if it's 64, then let's think about it. So 2, 4, 8, 16. I don't see too much property of regard to its digit. I don't see that. But okay, that's also one thing. So if it's power of 2, then could we no, I don't think so. So power of 2 is just power of 2 then. How to deduce, like given a string, how do I deduce if it is a power of 2 then? Just providing a string, how do I determine quickly enough? I should like give up this thought. So we should think about something else. What I mean is, just such possible outcome for power of 2, right? Between 1 to 10 power of 9. So it would be like 2, 4, start with 1, 2, 4, 8, 16, 32, 64, 128, 256, 5, 512, 1024, 2048 dash 96. Just those outcome and and then we can then thought is we can put the above output into array. Not array, like into a vector that maps digit to a string. Then we see digit, we see the number n, and we convert it to a string, and we go through those digits, those corresponding potential power of 2, and see if any number matches. And that's my idea right now. So actually shouldn't be hard to implement, so that I could do a while loop at here. let me just write it down. So the initial number obviously could be just 1. So I will say int I equal to 1, and while I is smaller than the int max, then yeah, because I don't want it exceed int max. Actually, no, I don't know what I'm doing here. So smaller than int max. Actually, I should give because it's a floating number, so maybe it's not a good idea. I just make it 64.t, and then you know what? We just use some math here, so we'll know that 64t is just a 64-bit number, so that its maximum power of 2 would be just just 1000 ish, like this form. And since there are 64 bits, so this will be 64-bit 0. I mean 630. Okay, cool. And so that I declare counter here, counter equal to 0, and we can do like counter less than 64, I guess. Counter, sorry. I mean, wait, let me think about it. 1, 2, 3. Yeah, that's correct. Okay, so counter less than 64, and each time counter less than 64, we can just make I times equal by 2, and we convert it to a string, and we put here into our vector that maps digit to string, which is vector. I mean, here we can do a map by like white border, right? White border. Yeah, just vector string, and we call it VVS. Nice. Just call it VVS, and then at here. Actually, also at here, like because it's less than 10 power of 9, so maybe we can initialize it, right? I'm gonna just initialize 20. I mean, like it's safe, and I don't see it cause too much space issue. So come on, it's Leetcode, it's not real programming. So wait, yeah, that's 20. 20 is enough, right? I don't have to initialize a vector string. So at here I got a container. I mean, I will call a container that maps digit length to actual string, which is power of 2. Okay, here another decision comes over. So do I want it to be string, or I want it to be something else? So potentially we can have an int, we can have string, or we can have some sort of just count of digits. So we can, I mean, yeah, but we can do that step doing by string, I guess. Yeah, what should I mean, yeah, just let's just keep it this way, and we can see if we can do some improvement upon this solution. And here we will first convert this number to a string, and which we will do so in C++. Actually, I'm not sure if C++ is good language for this. Like, but anyway, I will do that. So I will do it str, just name it randomly, doesn't matter, and I will do I dot to string. I mean, wait, actually, to string. I think C++ is like to yes, it's not object oriented for this number, so should be doing this to string. Actually, one thing about how I then also I need counter plus plus. Oh, I can write a for loop here. That's stupid. Okay, anyway, okay, upon here, I would have the above, and we convert number to sorry, here I forgot to insert. So what I will do is VVS dot string dot size -1, because yeah, we start with 1. So yeah, that's and then push back, just push back the thing we wanted. Push back str. So we will push back string. Okay, sounds good to me. And up in here, I would have above and then yeah, let's convert. So string tmp, 我就可以 tmp to string n, and then we we can do something like all to, I mean not, oh that's so stupid. We just call it vector string potential, like you know the potential matcher, and this potential matcher will be potential match between the string to this number will be VVS. Sorry, I should use this scripting element. I want tmp dot size, and also I want t-1, and here it is. So before we do anything here, let's just like print out the potential strings. So what I will do is just print out one of them and see if it works. Return false. And yeah. Oh, it's not toString. C++ convert. I searched this for many times because it just happens. You okay? toString. I see. That's actually funny, but let's get over it. Oh, nice. Here we got toString and out then out. Okay, that sounds correct. Let me do one more. So potential 1 should be 2, and let's do a 3, 8, cool, and the 4 should be runtime error, cry. Okay, okie dokie, and then we just go through it. So for R2 S, R2 S of potential, and do a potential here, and then we want to see if the arrangement is possible. I mean, like see if we can transfer one to another. So here I need another function which will take we just call it helper to make it easier, and it should take two string, which is one string is the it doesn't matter the sequence. I just want to see if 2 is possible to transfer from each other. So I just call it S1 and S2 would be enough. And then how would I do it? Is like we just do it generally. Also I'm here like I'm utilize the thing is that it's C++, so they use ASCII instead of Unicode. So yeah, they should use ASCII, right? Yeah, I think so. Okay, anyway, do I need a vector? I'm not sure if I would need a vector. So here we just call vi, and then it should be 10 and 0. Initially to be 0, actually I don't need 0, but I still did that anyway. And then we just traversing it. So R2 C S1, and then we just do vic minus 0 plus plus, and here I'm gonna do another run. S2, and then we just check. So if suppose that vic equal to 0, then return false, and here vic minus minus decrement it and return true. For more explanation for this part, we just simply creating a vector that store our count of each digit, and then we traversing the other string and do that once again. So if they are matching with each other, then also just one precondition, which is the length of string is the same, so they should have the same number of characters, so that if this holds, then it should be true. So here like let's give one example. So here I may have a number called 101 and another S2 would be 110, so that in my vector int what will happen is that it goes to my first and it count 1, so index 1 will be have 2, and then index 0 would have 1, and for the string 2 it would do the same thing. it will first traverse to 1 and see if 2 then decrement here, then he'll see another 1 and decrement here once again and see 0 and decrement here, and upon that here everything is perfect match, so it will return true. And another case would be like if it's 1, 2, 0, so upon the first one it will be something like this, but it goes to 2, but 2 since it's no initial, it will be initialized to be 0, and then it will simply return false. That's, yeah, I think that's it. And okay, so here I call this function, I call it helper. I love helper function. Helper function is very useful, you know. And s and tmp, if this is true, then return true, else I just ignore this and let it travel to next potential outcome. And then if it come to here, then it means it's always false. Let's see if it worked. Oh, quantum error. Okay, interesting. Oh right, here I didn't do I didn't do that. So it's ASCII. I have to convert here between ASCII 0 to. Okay, let's see if it works. Great. I don't know. Give some random outcome. Cool. I think work, but like try some outcomes that could be resulting 2 power of like 2 power of 16, which is 6, 5, 5, 3, 6, and we can make some 6s, 5, 5, 3, 5, 5, 3, 6, 6, and see if it's working. And it worked, and let's try something different. So let's try some rather large number. So how about 2 power of 60? Oh, it's too big, sorry. So let's try 2 power of 40 then. Oh, sorry, it's still so big. I couldn't see the result on my calculator, so it's hard for me to test it. I think logic for my program is working well, really well. So let's try power of 22, and then I get a very large number, and it's great. I have a large number, and it's very good for my testing purpose. And yeah, and then we can rearrange some to make sure that our program is working. So we just do a few variants to verify if my program is working or not. Return if it's working. Okay, cool. I'm gonna submit. Okay. Wait, are you sure? Like faster than 35%. Okay, that's not very good. But yeah, I'm thinking like I have made. I mean, I don't know. Some of this I may have some overcalculation at this part, because each time I'm using one string is from the potential outcome, which that part I need to calculate each time. But for this part, I may do something bad. So, but anyway, let's be honest, 8 milliseconds is fast enough. So, yeah, guys, that's it. That's today's problem. Thank you for watching.